When you are working on your own machine learning projects, it is absolutely essential that you are clear on whether your data set requires regressors or classifiers. These are different types of machine learning algorithms. So let's take a look at the difference between regression and classification. Okay, let's start with regression. Regression is a group of machine learning algorithms that predict data when the target column may take on a range of continuous values. Okay, regression is quantifiable and fits anywhere on an interval. So I tend to think of regression as like if think about math where you have x and y and you're plotting a curve. Well, generally speaking, x can take on any range of values. Now, when we say continuous here, we're not talking about the mathematically precise, like, well, you must have 100 decimal places. No, we just mean like, you know what? Maybe it takes on any range of value between 1 and 100, for instance. That would be regression. Okay? And so the idea of the choice as to whether your data set is whether it requires regression or classification depends on the target column, which is what you're trying to predict. What is your y? So here's some examples of some different y values that would use regression algorithms. We start with height and distance. Okay, right? Height could be, I mean, it doesn't take on any range, but you know, it's going to be between like 4 feet and 7 feet most of the time. Distance would depend on what it is that you're measuring. Revenue, how much people can make. And you know, when you think of straight lines, like it can be okay sometimes to take on negative values, even though that's impractical. Think of regression as, you know what? If it was just 2 dimensions, conceivably you could map it with a line. And population is another case of something that would take on a wide range of different numbers. Think about it like that. If your output column is a bunch of different numbers, you know, money, number of people, distance, etc., that's regression. Now, let's contrast that with classification. So for classification, now we're looking at a target column that's taking on labels, which could be distinct from numbers here, or very few discrete values, okay? So the classification is usually 0 or 1. It's this or that, or it could be labeled by words. So let's take a look at some target columns, some different y values, which would put you in the group of classification algorithms. So we've got color labels. Okay, you could have a bunch of data and maybe the output is red, blue, or green, for instance, okay? And I will say this, with classification, it's most commonly just 2 values or 2 labels, but it could be more, okay? If it's a lot more, you know, then I would put on the brakes a little bit. Binary image recognition, the idea here is that images, which can be classified in a lot of different ways, is it this person or not? Okay, that's a binary image recognition. It's a yes or a no, which you can convert to a 0 or a 1. Is somebody's height over 6 feet? Okay, you can change height, which is a continuous range of values, to the question of whether it's over 6 feet or not. Now it becomes a 0 or 1, which would be a classification algorithm that you need. Does a user click on an ad? Yes or no, okay? That's a label, which would also be converted to 0, 1, and that would work as classification. Note that the machine learning models work well with 0 or 1 instead of, say, the actual labels, but it is different. Like if you're picking color labels, you don't want to do it like 0, 1, 2 if the 0 and the 2 are farther away from each other. You can actually leave them as distinct labels, but regardless, classification algorithms split into groups. That is the key idea. And just to wrap this idea of the multiple classifiers, those do require sometimes, you know, a different machine learning. Sometimes it's a scoring metric or something else that you need to change to state that it's a multi-classifier instead of a single. Okay, let's look at some data sets and decide whether they are in fact classification or regression. Let's start with the bike rentals data. Okay, here's some real data. Now, data itself is not regression or classification. It depends on what your Y value is. What are you trying to predict? So the standard here might be DF count. How many bike rentals are there? Take a look at that column. You see a range of values just in the first 5 rows between 801 and 1600. So is this regression or classification? Take a moment to decide for yourself. And hopefully you said regression. So what's our reasoning? Well, Y takes on a continuous range of values, right? The count could be, anything within a general range, okay? And again, totally fine, like that it's not decimals, right? It's not gonna be decimal point. Your model could result in decimal point predictions, but then you just round them, okay? All right, next, let's take a look at some exoplanet data. Okay, so here's some exoplanet data. You see the dots there because these are measurements of light flux, and there are, I don't remember how many, I think tens of thousands of columns. Okay, so they cannot all be shown. Now, in this particular case, what people are trying to predict usually is the label, and we see 2 and 1 here. Now, you would want to do research on your data set to figure out what are the ranges of labels here. So you could do df.value counts, parentheses, label in quotes, and you would see that they all are 2 or 1. It's most common to label as 1 and 0 because those have clear meanings, but sometimes the data that people store is the data that you get. And so if that in fact is our Y, take a moment for yourself and decide, is this regression or classification? Okay, hopefully you said classification. So what's the reasoning? Y is 2 or 1. A star has an exoplanet or it doesn't. That's it. It can be helpful sometimes to kind of look at the machine learning problem in terms of the output, in terms of actual language, right? Because the purpose of this data set is, does a star have an exoplanet or not? Okay, that is a yes or no question, right? And that's very different than the bike rentals algorithm, which states how many bike rentals are there, right? That's a quantifiable question. This is a classification question. Okay, next, let's look at some climate change data. So here we have some climate change data. We see some different columns here. The big question for us would be, what is our Y value? What are we trying to predict? And, there's not a right or wrong with what you're trying to predict. Common here is temperature, okay? Can we predict what the temperature is given these other, attributes? And so take a look at the temperature column. We see ranges just between 0.109 and 0.176. So clearly this is scaled, right? This is not, or it's not the classic Fahrenheit temperatures that we use. And the big question is it regression or classification? Take a moment for yourself to think about it. Hopefully you said regression. So why is it regression? Well, Y ranges over many values. The temperature could be anything, and think about the idea of an interval, right? If this is the range, if it's just between 0.109 and 0.176, it's not restricted of the values it can take within that range. So, you may or may not know in math, if you're looking at continuous real numbers, there's as many real numbers between 0 and 1 as there are between, actually all of them. I was going to say between 0 and 100, but between all of them is because of the amount of decimal places. So this is definitely regression. Okay, one more. Let's take a look at the census data. Okay, here we have the census data. And big question, of course, what is Y? Well, Y here is DF income. Now, when we look at the values shown, and you always want to look to see, of what all the possibilities are. if you need more information, because here I see less than or equal to 50K and greater than 50K. Are those the only possibilities? Well, you would want to run a df.value counts on income and check. And it turns out I will tell you that those are the only possibilities. So given that additional information, is it regression or classification? Take a moment to figure it out. And hopefully you said classification. Why? Because Y can be represented as 1 or 0. Okay, that's how it would probably be coded. And here it's greater than 50K or not. You know, it's an either or, and an either or is pretty much always classification because you're classifying it into two groups. Okay, so those are some kind of examples. And just to like look here, just like let's consider maybe a couple others. Like what if your Y was hours per week? Well, this is a range of values. This is going to be regression. Okay, what about even education number? Okay, it's a limited range of values. This doesn't tell us the full range. But when you have sort of numerical values, and clearly not 12 is greater than 9 is meaningful, and certainly there are higher ones here, you want regression. Okay, and that's something you could think about with education. Like what about grade point averages in US schools? You know, they're between 0 and 4, right? That's only 4 options, but because like, you know, a 2.7 is higher than a 2.2, you definitely want regression for something like that. Okay, so what are some tips, you know, as far as choosing between regression and classification? Number one is that it's usually a clear choice. Okay, it's rare to find these sort of like, ooh, could I do this as maybe classification, like the grade point averages? Maybe. Okay, usually it's clear. If in doubt, I would say experiment, meaning you could try either and see what the results are, or ask your learning community, okay, where there might be others who can advise you. And importantly, note that all regression data sets may be turned into classification. We had the height example where height, just in general, hey, it could take on all these values, but you could switch it to whether someone's over 6 feet or not, and then it does become a classification problem. All you have to do is find a place to split the data. And another example here, was the cab ride over $10, yes or no? So if you're predicting cab rides, how much is the cost? Full range of values, but you know, over 10, yes or no? Okay. And you can find better results sometimes if you change a regression data set into classification and your work may be original. So hopefully that gives you all like a good sense of the difference between regression and classification in terms of the machine learning world. And it is absolutely essential that you are clear on whether your project requires a machine learning regressor or a machine learning classifier to give you the best possible predictions.